So excited for space, and so is everyone else. This is so awkward. Okay, I'm live. And what the hell is up with space? I'm just giddy over this topic because I don't know anything about space. This is not an understatement. I kind of try to soak it up. It's not really my forte, and I know saying on that on the internet is kind of taboo. But I don't really know much about space. I don't really like space, probably because I don't know too much. But really excited for today because we're going to jump into space and like what how we look at galaxies, and I've got a horrible spoiler about our Milky Way pictures that I just found out. And anyway, let's get right to it because Stephanie Hamilton is amazing. She's a good friend of mine. She just completed her PhD, and she's actually now working over at the MIT School of Engineering Dean Office doing technical communications. She's an all-star science communicator. Could just go on about how awesome she is for way too long, but let's just get to it. Hey, Stephanie, how are you doing?
Hey, good. I'm uncomfortable with all those nice things.
What up, grad school?
Hey.
Hey, but yeah, so you're in Boston now, is that right, or are you elsewhere?
Uh, Officially, I'm in Boston right now. I'm visiting my partner in Ithaca, New York. He goes to school at Cornell. So
Nice, nice.
temporarily quarantining here in New York, but normally based in Boston, yes.
Can we call it Cornell teaming?
Hmm?
Can we call it Cornell teaming? Is that that's not a thing? Okay. Um,
Maybe people at Cornell are calling it that. I don't know.
yeah, let's go with it.
All right.
All right, so yeah, let's get going. We're gonna save the Milky Way thing for a minute because that's a lot. But other people have way better questions for me. I have started looking into space. I asked the internet what I should be interested in. People are all over the place with what they think is cool about space because it's this huge topic. And you did a lot of work studying this. Could you just really quickly outline kind of what your research was about? Like, what was the basis of your work?
Yeah, so I spent my PhD trying to learn more about how our solar system formed and evolved. And so I was using a project called the Dark Energy Survey to study not dark energy. In fact, I was using it to study our own solar system. So this project was taking pictures repeatedly of lots of galaxies in the southern hemisphere sky, and we realized that we could repurpose it to do something completely different, and it actually worked. And so we've found, or my research group has found well over 300 new things out orbiting the sun beyond Neptune at this point. And so it's actually been very fruitful and really exciting to see this big project be repurposed for something it wasn't designed for at all.
Okay, so that's really interesting. Because I didn't I so things that are circling Earth. I know there's like an asteroid belt. Is that what we're talking? What is or not circling Earth?
Sort of.
Sorry, that's the moon. Oh God. I told you beforehand this is going to be real basic.
We've moved past the geocentric framing of our solar.
I mean, I just think it's really cool that everything circles us, even though, it's a flat plane. Um,
I know.
okay,
It's wild.
so what are the other things that are circling the sun?
Yeah, so the main components of the solar system are the four inner terrestrial planets, Mercury, Venus, Earth, and Mars. And then are separated by this asteroid belt, which is made up of much smaller, rockier, like lumpy things. Like they're much, much smaller than planets or moons or anything like that. And then you have the gas giant planets, Jupiter, Saturn, Uranus, Neptune. And then beyond Neptune, there's another sort of asteroid belt. It's called the Kuiper Belt. And that one, it's very similar to the asteroid belt, except it's much bigger in that it contains more mass, and it also extends much farther in physical space. The other key difference is that it's much farther away from the sun, so the objects in this region have a lot of ice and stuff on them. So I like to call it basically a second icy asteroid belt out beyond Neptune.
Okay, this is totally, I mean, I guess it's tangential, but when we say ice, is that liquid water? What is this ice?
Water, yeah. So water ice is. one of the ices, but you can also have dry ice, like carbon dioxide ice. You can have nitrogen ice. You can basically any of these they're called volatile compounds.
Yeah, I
that
studied
sort of
some of
all
that in
fall
my
in this water,
yeah.
water, carbon dioxide, nitrogen sort of realm of stuff
Yeah.
can all form ice on the surface of something way out there. Yeah.
Nice. Yeah, we've got Matthew DeForest popping in here in our chat for everyone who's on here. There's a bunch of people listening because space is rad. So Matthew says, how many additional planets are likely out in Neptunian space? What is that?
Ooh.
Does that mean just outside Neptune?
Well, that's a good question. I actually worked on this for my PhD. Not answering exactly that question, but there is a recently proposed new planet called Planet 9, which is hypothesized to be about the size of Neptune, maybe a little smaller than Neptune.
Mm-hmm.
And we don't know if it exists. No one's seen it. But we look out and we look at the most distant trans-Neptunian objects, or these Kuiper Belt objects, the ones that take the longest to go around the sun.
Mm-hmm.
And they all look like their orbits are pointed in the same direction in physical space. And that's really weird because gravity is random. Interactions of these things with other things in the solar system are random. So you would expect them to be oriented randomly, but they're not. Oh. And so the big question that I was trying to address with my PhD thesis was, okay, is this an effect of observation? Like, are we just happening to look in exactly the right place so that it looks like these things are all lined up? But really, if we looked elsewhere, we would find other objects that aren't lined up with those other ones. Or is this a real effect? And is there something else out there that we don't know of that is essentially forcing these objects to point, their orbits to point in that direction? And so turns out this question is actually really hard to answer, only partially because we don't know of very many objects, and small number statistics are a thing. Like, you can't really say very much about 4 or 10 or 12 objects. You need a much bigger sample size. So unfortunately, the conclusion of my thesis was we need more data, but
always the
so
fun one.
From just that alone, I can't tell you if there's another planet out there. It'd be really cool if there was, but I personally am staying a bit skeptical until someone actually shows me images with a new planet in them.
It's kind of the Pixar didn't happen of space.
Right, exactly.
I'm going to get back to Pluto because I have strong feelings about Pluto. It's the only thing I have strong feelings about.
Everyone has strong feelings about Pluto.
Yes, but I want to address what we talked about right before we started talking and kind of what I hinted at. Where is this question? Because I didn't even think of this question. There's some really interesting things. Okay, so Harin_R on Instagram asked, how can we capture our whole Milky Way photo? This is something I've thought about. Like, you see those beautiful everything in the sky photo, and it's like, oh my gosh, I'm a tiny dot in that. But we're a tiny dot in that. How do we get that photo?
Yeah, so the furthest thing that humanity has ever sent anywhere are the 2 Voyager spacecraft that NASA launched in the 70s. Okay. And those are about 4 times farther away from the sun than Pluto is. Okay. And the Milky Way is much, 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 much bigger than that. So there's no way that we've been able to get something, out of the plane of the galaxy looking down. So unfortunately, those pictures aren't actually real. But they are based on real data. So we are able to catalog the stars in the Milky Way. We can learn about where they are sort of like in the plane, and then also how far away from us they are to create a sort of 3D model. And so the pictures that you see of the Milky Way are, they are based on real data. They are using stars that we've measured. We know how far away they are. We know where in the galaxy they are. And so you sort of like take that information and then you sort of shift your frame of reference so that you're looking down. So it's not a real picture, but it's based on real data.
Sure. So I guess that's kind of how MRIs work too, right? It's like you just kind of triangulate a bunch of different pieces.
Yeah.
All right. Well, I will accept that answer.
It's not totally fake. It's just not totally real either.
All right. Well, yeah, but it's pretty, so that's what's important.
Yes.
All right. So going back to my strong opinions about Pluto, I am pro Pluto, not for any reason, but just because I think it's adorable. It's a cute little thing. Pro Pluto meaning that I wish it was a planet. That was somewhat recent in terms of space study that we decided it wasn't a planet.
Yeah, that happened in 2006 is when that vote in the astronomy community took place. And the reason it did is because, I mean, the classification of Pluto as a planet sort of was ascribing to it properties that maybe it didn't necessarily have. And then also, if you call Pluto a planet, then you have to call a bunch of other things in the solar system planets too, which like could be fine. Like that could be fine. I mean, can you imagine the saying that elementary school kids would have to learn then, though, if you had like 20 extra letters you had to memorize?
Yeah, that's true. Okay. All right.
But I mean, that in and itself is not a great reason. And it's mostly because if you are looking at a condensed snapshot of the solar system, so you see like the 4 terrestrial planets and then the 4 gas giant planets and then Pluto, sort of like something doesn't fit in here. Like Pluto is way, way, way smaller. And then there's also the fact that it actually sits in the Kuiper Belt.
Really?
So it's actually, yes. And so it's actually just one rock. I mean, it's much bigger than a rock, but it's just one object of thousands or tens of thousands of objects out in that region. And so sure, it's the biggest. It was the first one that was discovered, but I'm not sure that distinguishes it sufficiently from the others. It also doesn't completely fit in with those either. Like it is geologically active. There are basically the equivalent of volcanoes, but with water ice or water and ice rather than rock. And so, I mean, it is a very cool, interesting place. It sort of doesn't fit with either of the two. So that's sort of where the dwarf planet designation came from. And so one of the reasons that the designation is important is it sort of frames how you think about the object. Obviously, I mean, people are upset that Pluto's not a planet anymore. And the framing and how you think about the object has become different with its reclassification. But like naming things is of some importance.
Yeah.
Like what class of objects, there's probably a different formation mechanism that Pluto underwent rather than something like, well, definitely the gas giants, Jupiter, Saturn, Uranus, and Neptune. Like it formed much differently than those did. And so it's all sort of about what you want to learn about the thing.
Sure.
And so this is, I mean, I feel like I'm rambling, but this is also the reason why this debate is still ongoing.
Yeah.
Is because no one can quite decide what are the most important aspects and how those should play into something's designation. It's a very complicated question.
Okay, well, I feel better about that because if everyone was like, no, it's for sure not a planet, I'd probably have to drop my campaign. But
I will say that nostalgia is not necessarily a great reason.
Yeah, that's the only reason I got is that I was like, oh, Pluto, it's so cute. But I
do love Pluto. Like I really love Pluto.
Yeah.
Oh, I also have this tattoo
What is
that is the solar system, and the reason I included the Kuiper Belt here was so I could put Pluto in the Kuiper Belt. And so it's like my permanent science communication prop to be like, oh, why isn't Pluto a planet? Oh, well, this is why.
Because my tattoo.
Because it's not alone out there.
All right. Actually, I'm totally down with this. I think this has been a success already.
That was a long-winded answer.
No, I mean, but it's what we needed. And the fact that you had like a prop built in, That's so rad. That's so cool. Okay, so we got a bunch of questions. If people are, you can't see my face, but people watching can see my face, and I keep reacting very strongly, randomly.
Uh-oh.
No, the questions are so good. We're kind of all over the place. So, um, Agent question mark, so Mark, asked, when I was a child, Jupiter had 14 moons. What's the total now, and were any captured in the last 40 years, or did we just not see them before? I don't know what that one means, but like, oh, I get
Yeah.
it.
Yeah, so I think now Jupiter has 69 known moons.
Nice.
And most of those are because our technology, our cameras just weren't good enough to see them, or we weren't looking in quite the right spot. So most of those have been discovered as our technology gets better. But there are likely many thousands more that we still haven't found yet. Like 69 is like the tip of the iceberg.
You really
in
cannot
terms
say
of how
that
many
along
moons
with
Jupiter
69,
had.
by the way.
I know. I did.
You did.
It happened.
You did. Welcome to Asking I'm a Scientist, where that is actually encouraged. I'm not sure what I'm encouraging. Anyway, so, and so it sounds like, so what Mark was saying with, were any captured? My brain was like, we didn't catch any. But asking, like, is Jupiter gathering more moons? Is this something that happens? Maybe that's not the case in this situation, but like, I guess planets have to capture more moons?
Yes.
Oh, no.
Yeah. So I don't know specifically of any that were captured just in the last 40 years. I mean, that doesn't mean that isn't a thing or that didn't happen, but I just don't know. But yes, this is a thing that is constantly ongoing. And there are also, constantly moons that are leaving Jupiter's orbit. So these are essentially in unstable orbits. And so they'll get captured by Jupiter or by any planet, really, and linger for a little bit, may orbit a few times, or stick around for 40 years. I don't know, but then eventually leave. So this unstable orbit basically means that it wasn't there since the beginning of the solar system, or it won't stay for the foreseeable future. It'll leave at some point. And so this actually just happened with Earth. Back in February, we captured our own new mini moon that I don't even know if it was a kilometer in diameter. It was super tiny. But it stuck around for a year. We only discovered it in February, and the astronomers estimated it had been in orbit for a year.
Wow.
And then it escaped just due to like tugs from the moon and other things. It wasn't in a stable orbit. We knew it was going to leave eventually. And I think at the end of February, it was discovered, and then of course astronomers were tracking it and getting tons of observations every night, so we saw exactly when it left. And it's now in orbit around the sun, not Earth anymore. We had a tiny friend for a moment in time, and now it's gone. There will be more.
There will be more. Old friends, new friends.
Yes.
Excellent. Okay. So let's see. I mean, I hope you understand this one. Jared says, are there any theories as to what the, in capitals, Great Attractor is at the center of the Laniakea supercluster? Do any of these make sense?
Ooh, I am not a galaxy person, so I'm sorry.
Okay.
Yeah,
We'll find
I'm
a
not
galaxy
sure.
person. God, there's so many. I think this is what's actually really interesting about space, and maybe why I don't get into it, is that when we say space, it's sort of like saying biology, right?
Yes. Oh, yes.
And so what is the difference? Wow, this is equally as useless as like what is biology, but like what's the difference between galactic and or like the solar system versus galactic studies? Are those like totally separate fields?
Mm-hmm. Yep. Yeah. So I consider myself a planetary scientist.
Okay.
I study planetary bodies, so anything in orbit around a star, essentially. And so by studying our own solar system, you can learn about other solar systems in our galaxy. But that doesn't take into account like interactions between stars itself and stars in the interstellar medium, which is like sort of just the gas that is in between all the stars. And then galaxies themselves, you essentially ignore the effects of individual stars and just consider the galaxy as a whole. So it's like, it's really the scale of what you're talking about. So the solar system is the smallest of those scales. And then you can talk about like star clusters and parts of a galaxy, and then galaxies, and then galaxy clusters, which are just giant collections of galaxies. It's just, so there's a lot to study in astronomy.
I'm going to consider you a space microbiologist or a microcosmologist.
Yeah, hey, there we go.
And actually, speaking of that, we've had a couple questions that are really interesting. Hemang Purohit, we'll see if that's even close, asked, like, what's a good starting point of learning about cosmology? And then also asked, are there any books or like how do you, I guess I have this question too, of how do you get into this kind of stuff?
Yeah. So there are a lot of popular science books that are really good for these kinds of things. Anything by like Stephen Hawking would be great. There are, oh my gosh, of course, now I'm blanking.
That's okay. The nice thing, we'll make people come back to the video, because after we talk, I will send you an email and then your brain will turn right back on, because that's how this always works.
Because I have a book list online of some good science books. And so if you come back to the description of this video, I'll make sure that Susanna gets that list and can put it there.
Yes, absolutely. No, I'm excited. Yeah, because I need that as well. So we've got Daniel Whiteson, who is like teaching us all the things.
Daniel, hi.
Oh, you know him? Oh, sweet.
Yeah.
So he's got you covered as far as the galactic stuff. He says the Great Attractor is a mysterious source of gravity about 150 to 250 million light years away. We can't see what's there because it's behind the Milky Way. It has the gravity of 10 quadrillion suns, which sounds like a fake number. But that's
it's
rad.
not.
But it's not. I just can't understand.
No.
This is awesome. Gosh, the questions that come through this. I love this show, not because of it, like, I don't know if anyone else finds it useful, but honestly, it's just a great excuse for me to learn new science. And I mean, we've hung out before. We haven't talked about your science
I know
at all. So
we need to fix that.
Yeah, that needs to be, why is that not a thing? Anyway,
I know.
I'm excited for this one. Sarah Kern says, what's another controversial categorical change in space's history other than Pluto? Are there things that people are fighting over?
Ooh.
What happened to Planet X? Was that a thing?
So this Planet 9 thing is, I guess, just the latest iteration of Planet X. Planet X has come to mean just sort of any planet, any new hypothesized planet, whereas Planet 9 is like a specific version of it. Like it has a predicted orbit and predicted properties, whereas Planet X sort of just is a generic umbrella term, I guess, for anything that might be out there. In terms of other controversial topics,
I think about anything that I know of. I mean, okay, let's do this one. I want to do this one. Do you think that there's life out there?
Oh, absolutely. Yeah. Intelligent life, that's a different question. But life, just, even if it's just bacteria or single-celled organisms or something, like 100%.
Just bacteria. But I agree.
Just the universe is so huge, so that even if the probability of life is tiny, the universe is so huge that there's 100% chance that there's life elsewhere. Whether we will ever make contact with it or ever know about it, that's a different question.
Well, and I mean, is it possible that we won't even recognize it? I mean, I got all up in arms about calling a virus alive or not. But yeah, I mean, we have a kind of narrow classification of what life is. And we're always looking for life, but like, are we even going to recognize it if we ever saw it?
That I don't know. Yeah, I mean, so life as we know it is, carbon-based. I mean, we're looking for what we know because it's the only thing we know. Yeah. And so
Yeah.
It's entirely possible that some other like totally different type of life is out there somewhere and we wouldn't know because we're all we know. Like we're all we know
Yeah.
to look for.
Yeah. Yeah. That sounds like some sort of like popular 2000 song. We're all we know. I'm really glad. I'm looking through the questions on Instagram. Anybody who is on here knows that I post a space for people to ask questions just in case people miss the live show. But I'm really glad to see that Kelly Raptor also asked thoughts on Pluto and everyone 30 years or older resisting its declassification. We already covered that. Kelly, we can have a separate conversation.
Yeah. I mean,
I'm
I
just
do
kidding.
get the nostalgia. I'm a little sad about it too sometimes,
Yeah.
but like I also recognize the scientific reasoning for
Yeah.
why it happened.
I feel like this
Again,
could be like
there's
the millennial Gen Z cutoff, right?
yeah.
It's like, do you think Pluto is a
It could
planet?
be.
Okay, so Zinfei or Faye, sorry, Zinfei asked, how do you explore and discover new planets? If I were to send out a mini spacecraft, how far would it would I have to go? I guess those are two different things. So discovering new planets, or can we just send spacecrafts out and just like run into shit?
So I hate to break it to you,
Oh no.
but all those scenes in your favorite sci-fi movies where, you know, they're having to crazily dodge asteroids and stuff, like that's not real. Like you can fly straight through the asteroid belt and never hit anything. Empty space, like even the asteroid belt, which we think of as one of the denser regions of our solar system, it's still sparse as heck. Like there is still almost nothing there.
Okay.
So you basically have to know where the thing is that you're going to. Otherwise, you're probably not going to hit anything. In terms of finding new stuff, I can talk about how we did it in my
Yeah,
collaboration.
let's do that one. That makes sense.
All right. So the Dark Energy Survey, its basic premise was, you know, trying to look at the most distant galaxies to figure out the expansion of the universe and its eventual fate. Like, how is our universe going to end? I can't really speak to that because that's not what I studied, but the Dark Energy Survey was taking repeated images of the same part of the sky because if you like, we wanted to measure the faintest things, but if you just left the camera shutter open for as long as we needed to, the detector would get completely overwhelmed by all the light it was letting in. So instead of taking one long exposure, you take a bunch of shorter exposures, and then in using a computer, you add them together to make that effective long exposure. And so because we were doing this, we were visiting the same parts of the sky on different nights in sort of a cadence repeatedly.
Mm-hmm.
And so we are moving around the sun on Earth. We're looking out at the solar system, out at the cosmos from a moving platform. And so things that are closer to us will appear to move more against the background than stuff that's farther away. So this is exactly like if you take your finger, you stick it in front of your face. Anyone watching, you can please do this with me.
I'm doing
So I
it too.
don't
You're
look
fine.
like cool. All right. So if you keep it really close to your face and you blink one eye and then the other and then the other, your finger appears to move quite a lot against the background. But if you stick your finger out at arm's length and you do the same thing, your finger moves a lot less. And so this effect is called parallax. And that's what we were taking advantage of to try to find stuff in the outer solar system. So we would visit these same areas of the sky repeatedly and basically look for stuff that was like, look for points of light that were moving against the background and trying playing a game of connect the dots, essentially,
Mm-hmm.
to say, okay, this series of dots is the same object that's just moving from night to night. So this is actually just one object. It's just changed its position in the night sky from where we're viewing it.
Huh.
And so that's essentially the game we were playing with this data. We were trying to link, like connect the dots, essentially, to find new stuff.
Yeah.
And there are equations that you can work out that essentially tell you the path that these things should take across the sky. So that's how you know that it's actually an object as opposed to like just some random collection of dots that conspired to a line or something. So there are ways that you can check to make sure that it's actually what you're looking for. But yeah,
Huh.
that's effectively how you would find any new thing in the solar system. In other solar systems, it's a little bit different,
Huh.
because then essentially you're looking for the planet to go in front of the star and block out a little bit of its light.
Hmm.
And so we're talking like, 1 to 2% change in the light. Like your eye, you cannot see that with your eye. And
Challenge
so
accepted.
good luck.
Yeah.
So yeah, if you're looking for planets in other solar systems, that's one of the ways that you can try to find them, is to wait for them to cross in front of the star and block out a little bit of the light.
Huh. Okay. All right.
Yeah.
This is so cool. Unfortunately, we have to wrap up because we could talk forever. I think I'm going to
I
ask you
know.
to come back in the future because this was
Please
awesome.
do. I
Yeah.
would love to.
There's so many people have so many questions, and also I'll just let you know that people are fighting over which one of Saturn's moons are better. So you're going to have to go in and pop in there.
Ooh.
Yeah. But
Saturn has a lot of really awesome moons.
yeah, I mean, they've narrowed it down to a few for you, but
Oh, okay.
yeah, you have some options to choose from.
Yeah.
But before we go, like, what are you excited about? I know that you've done this job transition, and I don't know, I just finished my PhD, and I still love bacteria, but also, like, I also just don't want to think about my project anymore. Are you still excited about space? Are you still like wanting to learn stuff about it? What are you
Oh,
interested
yeah.
in? Okay, cool. Good.
Oh, yeah. Space is my jam. Like anyone, anyone who talks to me knows that I can just talk forever about astronomy and space and
Awesome.
all that kind of stuff. I think it's pretty common to get a little burnt out of your specific PhD project. So I would say that's definitely true for me.
Hmm.
But even planetary science, I can't get enough still. I love reading about stuff that's happening in the solar system and
That's
new
awesome.
NASA missions and all that kind of stuff.
It's so cool. Ah, it's so cool. Okay, yes, we're gonna do this again because there's so many questions that we did not get to.
Yes.
Okay, but anyway, your information is down below you. You're on Twitter, Instagram at SpaceSciSteph. Are you comfortable with people reaching out to you, chatting about big rocks that
Yeah.
circle large stars?
Yeah, of course. My DMs are open on both platforms. So
Nice,
please
nice.
reach out. I love talking about space with people.
Clearly, clearly. Well, Steph, you're awesome. I'm excited to one day see you again in person, but I feel like,
Yay.
yeah, we're gonna get those links for the book list and stuff down below. But yeah, you take care, and I will talk to you very soon.
Yeah, thanks for having me on. This was fun.
Of course. Okay, everyone, thank you so much for joining today. Please remember to like and subscribe. Just tells me to keep going, especially with everything that's going on right now. Regardless, though, I'm going to keep having these conversations. So it's really more of a question of, do you want to keep showing up and watching our faces move back and forth while we talk about science? But seriously, let me know what you're interested in. Let me know if there's somebody I should be talking to, if there's a topic you want to know about. Whatever it is, feel free to drop comments on these videos. I do check those, or go ahead and check out the other social medias that I have. Susanna L Harris. Send questions, and in the meantime, enjoy our planet as it is. And yes, things don't circle around the Earth except for the moon, and apparently passing mini moons, and also a lot of things that I don't know about. So I'm going to leave right now. Okay, bye.